In this section, we will focus on one of the most important parts of front-end planning, scope definition. After an owner identifies a business need and selects a preferred project concept, the next challenge is to translate that intent into a project that can actually be estimated, scheduled, designed, procured, and built. That is the purpose of scope definition. Scope definition is more than a simple list of features or wishes. It defines what is included, what is excluded, where the project begins and ends, what functions the facility must perform, and what assumptions the team is using as the basis for planning. This matters because without a defined scope, the project has no reliable baseline. Cost estimates remain rough, schedules are weak. Procurement planning may start too early, and project controls have nothing solid to measure against. A strong scope definition improves predictability, reduces change orders, and helps align the owner, designers, constructors, users, and operators around the same understanding of what the project must deliver. In other words, scope definition is where a business idea becomes a manageable construction project. A project concept is not the same thing as a defined scope. A concept may describe the general need, the type of facility, a possible site, and a rough order of magnitude estimate. At this stage, the owner may know what problem needs to be solved, but the project is still broad and uncertain. The movement from concept to defined scope is iterative. It typically develops through FEL2, where the team compares alternatives and selects a preferred concept, and FEL3, where the team develops the selected concept into a more complete project definition package. During concept selection, the team may compare different sites, building configurations, process technologies, delivery strategies, and phasing approaches. The goal is not to complete every design detail. The goal is to choose the option that best satisfies the owner's objectives and can realistically be delivered. Once the preferred option is selected, the team develops the defined scope. This includes requirements, site data, cost and schedule basis, procurement strategy, execution plan, and risk information. Construction input is especially important during this transition. Designers may focus on technical performance, but construction professionals bring knowledge of work sequencing, field constraints, trade coordination, procurement risks, and constructability. That early construction input helps make sure the scope is not only technically correct, but also buildable and aligned with the execution strategy. Once the project scope begins to take shape, it must be organized in a way the project team can manage. Three tools are especially important: the work breakdown structure, functional requirements, and scope boundaries. The work breakdown structure, or WBS, divides the project into manageable systems, areas, deliverables, work packages, or cost accounts. It gives the team a common language for estimating, scheduling, procurement, risk management, and progress measurement. Functional requirements describe what the facility must do. These are not just design preferences. They define required performance. For example, in a building project, functional requirements may include occupancy needs, room types, adjacency requirements, HVAC criteria, accessibility, security, and maintenance access. In an industrial project, they may include production capacity, process flow, utility demand, equipment performance, and safety systems. Scope boundaries are equally important. A good scope statement should explain not only what is included, but also what is excluded. This is where many projects get into trouble. If utility tie-ins, hazardous material abatement, owner-supplied equipment, or temporary facilities are not clearly defined, those issues can become claims, change orders, or delays later. A mature scope should answer four basic questions: what is being delivered, what performance is required, what is excluded, and what assumptions must remain true for the baseline to remain valid. If the team cannot answer those questions with evidence, the scope is not yet mature enough to support reliable execution. Now let's introduce the Project Definition Rating Index, commonly called PDRI. PDRI was developed by the Construction Industry Institute to help project teams evaluate how complete their project definition is before major authorization. It changes a broad and subjective question, "Are we ready to proceed?" into a structured review of specific definition elements. PDRI is not a design checklist, and it is not a substitute for professional judgment. Instead, it is a facilitated planning tool. It helps the team identify missing information, discuss assumptions, and prioritize the gaps that create the greatest execution risk. There are different PDRI versions for different project types, including industrial projects, building projects, infrastructure projects, and smaller capital projects. This is important because a complete definition package for a process plant is different from one for a university building, a bridge, or a small renovation project. Although the details vary, PDRI generally focuses on three major areas. The first is the basis of project decision. This addresses the business purpose, objectives, economic justification, and owner requirements. The second is the basis of design. This includes site data, equipment needs, technical criteria, building programming, and design parameters. The third is the execution approach. This includes procurement, contracting, project controls, schedule, safety, quality, risk management, and construction execution planning. PDRI uses a weighted scoring system, and lower scores indicate better project definition. But the score is not the only value. In many cases, the discussion that produces the score is even more valuable because it reveals assumptions and disagreements that might otherwise remain hidden. PDRI should not be treated as a one-time checklist. It is most useful when it is used as a recurring scope maturity tool throughout front-end planning. Early in FEP, a high score may be acceptable because the team is still evaluating alternatives. But as the project moves toward final authorization, the score should decrease because the project definition should become more complete. A commonly cited benchmark is the 200-point threshold. A PDRI score below 200 at final authorization generally suggests that the scope is mature enough to support detailed design and execution planning, assuming that high-risk items are closed or actively managed. A score between 200 and 300 suggests that important definition gaps likely remain. In that case, the owner should identify the highest weighted gaps and resolve them before releasing major funds. A score above 300 indicates weak scope maturity for a major commitment. The project may need to return to additional FEP work, revise its funding request, or proceed only with explicit executive acceptance of risk. A stagnant score is also a warning sign. It may mean that the team is producing documents but not actually resolving uncertainty. This is where PDRI becomes an alignment tool. Poorly defined PDRI elements should be linked directly to the risk register. Each major gap should have an assigned owner, a mitigation strategy, a target date, and contingency logic. For example, incomplete site surveys may become a risk related to unknown underground utilities. Unclear functional requirements may become a design and operations risk. Unconfirmed long lead equipment may become a procurement and schedule risk. PDRI helps the project team move from vague concern to specific risk-based action. Let's close with a case study involving a large public owner preparing for a major capital infrastructure renewal program. The owner faced aging facilities, complex utility systems, environmental constraints, and the need to maintain active operations. The business need was clear. The infrastructure had to be renewed and service continuity had to be protected. However, early planning reviews showed that the project definition was not yet strong enough to support a reliable execution baseline. Instead of treating scope definition as the responsibility of the design consultant alone, the owner formed an integrated project team. The team included project management, engineering, construction, operations, maintenance, environmental compliance, procurement, estimating, and scheduling. Using a facilitated PDRI assessment, the team identified several major gaps. The work breakdown structure was not stable enough to support cost coding and schedule control. Some design alternatives were still open. Site surveys and soil testing were incomplete. Permitting requirements had not been fully mapped, and the procurement strategy did not yet confirm critical long lead items. The value of the PDRI process was that it converted these concerns into action. Each gap was recorded, assigned to an owner, and given a due date. High-risk items were added to the risk register. The team completed additional investigations, clarified permit requirements, stabilized the WBS, and improved the basis of estimate and schedule logic. When the project returned to the next decision gate, the owner had a stronger and more defensible basis for authorization. The key lesson is simple. Major capital should not be committed just because a project is important. It should be committed when the project is sufficiently defined to be executed under a protected baseline. That is the central purpose of scope definition and PDRI in front-end planning.